Okay, hello everyone. We already missed some minutes. My name is Ala. I'm a data scientist here at SEB, and I'm very happy to be able to share our findings and knowledge on building and maintaining machine learning production pipeline at SEB. The bank was founded in the first place in 1856 and then merged with another bank in 1972, and the current SEB. We have different type of clients all around the world, and our hope is to be giving them the quality of the video. Okay, so let me re-share it again. Okay, I'm sharing my screen again. Okay, let's hope this is going to work now. But anyway, our goal is like a world-class service to clients, and in order to do that, we have different types of initiatives in the bank. You can see some of them from 2016 to recently. That one of the latest ones was to have a collaboration with Google Cloud. Also, same as many other companies, we have data science initiatives and competence and projects. Thank you for the comment. Okay, so we have also data science projects and the competence in the bank to basically help the clients. And if you're like me, a data scientist, you know that you usually start a data science projects with having some sort of POC, which is like a proof of concept. The POC for us data scientists usually start with some idea or business usually, and the first task is usually to collect the data, and then we do some experiments and hypothesis testing to get some insights, and then the next part of the job would be to build a model, which is usually to build a machine model. So usually the last part is to deliver the results. It would be in some way, for example, it can be some, I don't know, in PowerPoint level, it can be some Excel, or in some other ways. When we're doing this stuff, data scientists are doing these POC level projects, we're usually in some sandbox environment where we have some sort of full access and control on the environment. Also, it is possible that we might need to do the process for the POC multiple times. For example, when we get fresh data, we need to redo everything from data collection to delivery again and again. Also, it is possible that we as data scientists are involved in multiple POCs or these small projects. When we're working in a sandbox environment, we have to deal with multiple POCs. There are some challenges there, because the first thing is that the whole process is dependent on a data scientist, and you as a data scientist should again collect the data, retrain the model, produce the results and send the results, and also it makes the process very manual, in the sense that going from one stage to another stage, you as a data scientist need to do a lot of manual tasks. Also, it creates a lot of maintenance tasks for us, and probably we are not very happy and familiar with maintaining machine learning models. And even in some cases where you need near real-time response from your model, this is not even feasible. For example, for fraud detection, when the clients are doing transactions, you cannot wait or ask them to wait for some minutes or hours to see if the transactions is considered to be a fraudulent transactions or not. All in all, we see that there is a lot of talks and a lot of interest in putting models into production, which it seems to be a natural way of doing in the next level, going from POC level to having models into production. If you're a data scientist like me, and you've done multiple or a couple of successful POCs, and you see there is a change in the organization, there is a movement into putting your models into production, I think you're in the right place. There are a lot of other things that you are going to learn while pushing your model and also maintaining your model in production. However, if you're an organization or an employer having a team of data scientists keep them in POC level for a long time, then you need to know that after a while you're going to have a team of discouraged data scientists. So I think there is a kind of relationship between how fast you go from POC level to production and having a creative and encouraged data scientists. So I already mentioned that a lot of work and maintenance left when you want to go to production, and actually building a machine learning model is just at the tip of the iceberg. You probably already seen this photo, which showing different components of a real-world machine learning system, where you see the ML code is just a tiny bit in the middle. What comes next is that we, the same as many other companies, tried and started to push models into production, and leveraging best from our models. What I'm going to show and share the challenges and also lessons learned along the way. We're still learning new challenges, but here I'm going to share with you some of the challenges we had while moving into production. So to just recap, is that we said we have two environments. One is a sandbox environment when you do the POCs and you have kind of full control. Then you have a production environment. It can be a cloud, it can be on-prem, for example, a Hadoop cluster, or it can be some sort of Google Cloud platform. And we already mentioned that pushing models into production is not the final step of the machine learning lifecycle management. It's actually the beginning of monitoring its performance and making sure that it behaves as expected. For the first model, it went quite smooth because we have a very good team of data engineers could help us to kind of replicate our sandbox environment into our production environment and pushing stuff into the production environment. However, from the first model to the second, why? Because we figured out that we need to solve some issues and challenges. For example, version conflicts between different models. We need to isolate the models and their environment. You probably already know that there are some ways of doing it. A very popular one nowadays is a containerization. For example, Docker containers, where you deploy Docker containers into production. However, you need to beforehand think about having a production which can serve Docker containers. The other challenge we had was that from the very beginning of the moment we wanted to move into production, we figured out we need other competences. Not all data scientists or experienced software engineers, and you need to have other competences in order to maintain your machine learning. But we can say that a machine learning model has three different dimensions, in the sense that you have a code, you need to, it can be Python or something, or R maybe. You have a model, it might be a neural network, it might be some decision tree based or regression models, and also you have data. These three components are very essential to have a machine learning model. And since these dimensions are essential, so you also need to have different competences. You need data engineers to create the pipelines for you to move data around. You need machine learning. You need the machine learning engineers to implement your model efficiently. Scientists basically to make sense of the data and do some experimental tasks and so on. So in order to have a continuous delivery for machine learning applications, it is very important to have a cross-functional team. Also bear in mind that you also need a business person from the very beginning to the very end of your machine learning lifecycle management process. When you're doing some sort of software development, you probably very well know that you need some sort of tracking and versioning for your code. GitHub is very well known application for that. However, when you go for machine learning applications, you need to track even more. Not only the code would be enough to version and track. Your model and your experiments are actually based on trying different features, different algorithms, different parameters, or even different randomness. Also, a model is trained on your trained data. So you also need to track and version your data. So in order to be able to see what works, what didn't work during your experiments, and you go back to your model and see why the model is giving you this result, you probably need to check all of these parameters. You need to check the algorithm you chose, the features you looked at, the data, which time interval you consider for your training your model, and so on. So here was that you need to have the environment, capability tracking different things and not only the code. Also, after a while, you're going to get this question or request that the model is not performing as good as in the beginning, and you need to retrain your model. The very first question is that when you should train your model or retrain your model. Should you retrain it like regularly, on a regular basis, every day, every week, or every 6 months? Or you should start monitoring the data, and when the performance degrades, goes below some threshold, you retrain the model. The performance degradation almost always happens, and actually the moment you push your model into production, normally it has its best performance, and from that moment on, the performance starts to degrade. It might be because of the input deviation or data drift, or probably some other concept drift and so on. So in order to have continuous training, you need to also think about having some process for retraining your model and when to retrain your model. However, not only when retraining your model is important, where is also an important factor. It highly depends on the maturity of MLOPS in your organization, but there are basic kind of two options. In the first option, you ask your data scientist to retrain the model, for example, using fresh data, and deliver a new code to the production environment, and then it will be pushed into production and running. Another option is that you do the retraining or the retraining or training your model also continuously. You use a continuous training by generating and for retraining your model, and you push the source code into the production. Once you want to retrain the model, basically you don't need your data scientist to fetch the data, to do this stuff and push the model in the production environment. Basically, it can be done automatically. You need some monitoring, and also you need some triggering capability to be able to have this continuous training. So I touched upon some of the considerations here. There are even more considerations you need to consider when you are going to production environment. You need to think about if you want to have a batch or real-time model into production. It might affect the way, even the way that you are training your model. For some cases, for example, for fraud detection, if there is a card transaction, for example, it doesn't make sense maybe to go batch. You need to do it real time because you need the result near real time. Probably you need some sort of OpenShift environment or so. But for some cases, if you want to see which clients are going to churn at the end of the month, you probably do it in a batch, and then you maybe can do it in can launch a Spark job for that. There are some other security issues you need to take care of, and the reason is that when you have a model, your model is in some sense abstracts your data. You don't want to expose your data, and also when your model basically is exposed to your clients, you should be aware of some adversarial activities, in the sense that a person can come and start sending a lot of requests to your model and query the output. And by this pair, get to know how your model is working and probably try to attacks maybe. And the other thing, which is important, I think, is that we talked about we need to send the model, we need to send the metadata, but you need to also think about having a server in your production environment, which is capable of serving your models. If after some time you want to compare different models and choose which one should roll back, which one should go to production, you need to have a tracking server and also some metadata store to be able to serve the data and metadata store. And also, if you want to do some, for example, A/B testing, be capable of doing these comparisons. So we have learned, there are even more considerations, but what I have shown here was that the stuff that some of the stuff we learned along the way. learn them in the very beginning phase, but some of them kind of late and along the way we learn. The important thing is that when you are preparing model for production, even in your development phase, when you are doing a POC, you need to also consider these kind of issues, challenges, and considerations. I didn't touch upon, for example, ethical questions, but if you want to like remove the bias in your data, you should do it even in your trained model. If you want to follow some responsible AI principles, you should also consider it in your even training phase. So I try to go a little bit fast, so I hopefully can wrap up stuff here. So I have touched upon different challenges and different solutions that you can have when you are going into production environment. In the slides, what I'm going to do is I'm going to share some MLOPS processes from Google. They actually divided in the MLOPS paper into 3 different levels: level 0, 1. Level 0 is kind of very well known. It's called a manual process, where you have experimentation zone. If you look at the dashed line kind of in the middle, the horizontal dashed line, on top of that you have the experimentation zone or your sandbox where your data scientists are working, and below that you have the production zone. On top of experimentation zone, your data scientists, they do this stuff. They train a model and then they send the model to some machine learning model registry in the production environment, and then your data engineers and machine learning engineers are going to take care of the rest for the continuous continuous deployment part. And once you're according to your performance monitoring, the performance like the rate goes below some threshold, you need to ask your data scientists again in the experimentation zone to retrain the model to the production. The level 1 and level 2 are very much similar to each other, so I skip level 1. And in level 2, the main difference in the experimentation zone is that your data scientists, they train a model, but they don't send the model to production. They send actually the source code, which is generating this model into production. This source code is going to source code repository, and then after some CI/CD pipeline, it will be deployed in some continuous train or CT stage. CT stage is where, once needed, your code will run. It's going to find the best like a set of hyperparameter tuning and so on. It generates a model directly in the production environment, puts it into the machine learning model registry, and the rest is very much similar to the other part, except we have a trigger at the left, down left, trigger process, which triggers the continuous train stage when needed. So I want to here conclude this presentation. Thank you for listening to me so far. But before I end this session, I want to also stop here and share with you applications we are using or we have been using for different MLOps machine learning lifecycle management process we have in the bank. Yes, so I'm going to stop here. And first of all, thank you for your attention. So we have a question here regarding versioning of training data. So there are applications that you can use. I think I put the DVC here. If no. There are applications, softwares that you can use. There are other possibilities that we are also using is to kind of consider the data, the description of the data inside the metadata. So when we are saving metadata, we also save the data, for example, time interval. Also, there are some applications out there you can use for data version controlling. I think personally, I think we are not there compared to versioning of codes, but there are some tools you can use, and also, for example, ML Flow applications you can use to save version of the data or the data you use for training as your metadata. Yes. So I don't see any other question. If you have any, I hope it answered the question. Yeah. And regarding the versioning and storing the machine learning models, like tracking servers, one of the options we're using is the ML flow. We use it both for tracking the metadata and also tracking the model. So we push the models and metadata to ML flow. There are different servers to take care of it. And when we are pushing the data, basically you can log different things. You can also log the data if you don't want to use the application, they're ready to be used. Yes. 1 minute left. So I'll wait to see if we get any other question. Otherwise, thank you. I hope it was useful, giving you some insight along the way, and good luck with pushing your models into production. Thank you.